Hello, Sackville. I hope you're all doing very, very well. Trying to get my camera to work here. Hopefully it'll pick up and work out where it is. Anyway, I'll crack on. Hopefully you can hear me. Any problems with the sound, do let me know in the comments, please. So we are getting towards the end of this, really, aren't we? And this is called Additional Programming Techniques. Not the most exciting title, I'll grant you that much. But there's quite a lot in here, and I think this is often used to try to sort of separate out those who can program from those who struggle with it. So let's crack on without any further ado. I know you can see my main screen. You might not see my beautiful face because my camera's decided to not work. Just hang on 2 seconds. Turning it off and turning it on again. Any difference? Nah. Okay, we might need to persevere without a camera this time. Never mind. Anyway, let's not waste on time on that because you don't need to see my face too much. Okay, so here we are. So this from the specification. So we first of all got data types. I'm not going to spend too long on that. I think it's fairly straightforward. And obviously you need to know data types when it comes to programming, but there'll be maybe a 1 or a 2 mark question on data types just to check that you understand them. They often give you a series of situations. They'll say it's a phone number, it's a date, it's a password, and just ask you to tick which of these it is. So we'll have a look at those. Then we'll look at basic string manipulation and then the file handling, open, read, write, close, which sound difficult, but actually learning the code is as simple as open, read, write, close, but it's when to use it that's a bit more of a challenge there. Then we'll look at SQL. Oh, hello, I'm in the room. I'm back. Hurrah. There we are. There we go. Everyone can relax. You can see my face. I hope you guys are good. And then we'll dip into arrays and subprograms. We'll have a look at functions and procedures. There's an awful lot in here, so I'm not sure we'll have much time for quizzing. But if there's anything here that doesn't make sense, just say something in the comments and I will pick it up for you. Right, 10-minute teach. I've got to say that is pretty optimistic. It ain't going to take 10 minutes, but hopefully it'll be more like 35, 40. All right, so let's crack on with this. So first of all, we'll dip in and have a look at the sort of basic stuff that you're expected to know, and that is to do with data types. Obviously, you can cast data to work. Data is designed. These data types are designed so they're going to work with different types of data. So, for example, let's pick the easy one first of all. We've got Boolean, which is yes or no, true or false. So if they give you a grid, that's the word I was looking for about 60 seconds ago. If they give you a grid and they give you a series of different scenarios, something like open or closed, pregnant or not pregnant, because that's something that is a binary thing. They probably won't use gender anymore. They'd probably be too afraid to do that. But anything that has only got 1 or 2 values is going to be Boolean. So that's the first thing. Nice and easy. Yes or no, true or false, okay? Then we've got string. Now, a string is probably the most flexible and useful data type because it can be anything. It can be 0 to 9. It can be any alphanumeric character. It can be any special characters. It can be whatever you like. So when you think of a password, that would be a string. Then we've got the next one, which is a character. And a character is, well, it's exactly the same as a string, except there's only one of them. So it's a single alphanumeric character. It could be H, it could be underscore, it could be P. So just one character, that's a character. Then we've got the float, and float and real for your purposes. If there is a decimal or it's a fraction, it'll be a decimal obviously because we're talking about computers, then that would be a float. And then the last one is an integer, which is a whole number. A couple of things before we jump off this is that it wouldn't be fair to say they try to catch you out. But I think they do try to catch you out because one of the examples they often like to use is they will put in their little grid something like a phone number. Ooh, that's an interesting spelling of phone number. Let's try that again. Phone number. There we go. Now, you would be tempted to say, oh, for a phone number, let's go for an integer because it's a whole number. And that makes sense, right? Problem is, it's not. You'd actually use a string instead for a phone number. Why? Well, there are various reasons why, but I think one of the easiest sort of rules that you can run over this is to ask yourself the question, is this number going to be used to perform calculations on? So are you going to be adding or subtracting for the phone number or dividing it with other phone numbers? No, you're not. In which case, use a string. So I think that works really, really well. That rule, I've never seen it fail, so that might be the one you want to use there. And I guess the other thing, integer. Yeah, what's the benefit of using an integer over a float? And I was just going to say that if you think about it, if you take the example of a float, you might think, well, I'll use a float rather than an integer just because you've got options there. But in fact, if you think about any float, even if it's a whole number, an integer like 1, the float will save it as 1.0 or 1.00. So space has to be allocated for these digits. So therefore, given that space is at a premium, you want to use as little memory as possible when you're writing a program. If you can get away with using an integer, use an integer, not a float. So that's pretty much as tricky as the data types will get. Again, any questions, just ask. And if you want to say hello, say hello. Right, these ones, the comparison operators, just a couple of things here. And you can use these, obviously, in your programming. When it comes to SQL, you'll get a chance to use these. So paper 2, you'll get a chance to use these in both section A and section B. Now, the one that I want to draw your attention to, first of all, is obviously this, because we have got equals and we've got equals equals. So when you are declaring a variable, you're going to say score equals 0. And when you do that, you are creating a variable, which is a location in memory that's got a name. And you're assigning it a value, okay? When you use the equals equals, that means you're comparing two sides of an equation or an argument. So when this equals equals that, when this is the same as that, so just think of equals equals as the same as. I think these are also all pretty straightforward. Apart from that, you've got the exclamation mark equals, which means not equal to. These ones are already all pretty straightforward. Don't forget, if it starts small, it's a less than. If it starts big, like this guy, it's a greater than, okay? These are all pretty obvious. Addition, subtraction, multiplication, and to the power of exponent. These ones confuse people a bit, and that is mod and div. So just a few quick examples with mod and div. Let's start with div, because that's easier. So div is simply represents the number of whole times that a number goes into another number. So here's an example. If we said 13 div 11, the answer would be 1, because 11 goes into 13 once. Okay, so that's all that it is, how many whole times one number goes into another. Then we've got mod. So for a mod, you perform the div, but then you just read out the remainder. So for example, if you said 12 mod 4, the mod would be 0, because if you divide it 12 by 4, it goes in 3 whole times, there's no remainder. If you said 13 mod 4, well, 4 goes in 3 times, that's 12, as a remainder of 1. So that would be 1. So that's the mod and div. And they sometimes weave in a question just to see if you understand that, because students struggle a bit with the mod. The div's a bit easier, but the mod is a slightly strange thing to remember. Obviously, we've got and, or, and not, and we'll get a chance to explore those a little bit more when we look at SQL. You had better be hoping that an SQL question turns up, because on the face of it, learning structured query language is a challenge, but you've only actually got 4 commands to remember. It's really quite easy, okay? So those are the common operators, and you'll get a chance to use those in paper 2. Right, so variables. I've kind of covered this. Age equals 3. When you write that down in as code, you are creating a name, you're creating an identifier in memory, which happens to be called age. You are setting its value as 3. Okay, simple as that. And then this becomes a variable is a box that's got something in it that you with a name that you can use. You can add it to itself. You can just use it when you're doing your programming. And it's obviously one of the most fundamental building blocks when you're coding, is thinking about, what variables do I need? And I recommend to my students that when you're doing something in paper 2, section B, start by thinking about the variables you need, and then just create those, okay? Assign those variables, declare those variables, and assign them a value, because the more that you can get rid of at the start of that sort of process, the easier the actual processing bit is in the middle. Create the boxes you need, and then just move forward on that basis. So a constant, right? And by the way, in the exam, they may well ask you to define what a variable is. And you should say a couple of things along the lines of it is a value which is stored in memory, but its value can change or may change when the program is running. Obviously, you can change the value of a variable when you're writing the code at any time you like, but it's when a program's running that that a variable may change. Okay. So yes, it's yeah. So that's what it's used for. Then we go on to constant. Exactly the same thing. It's a value which cannot change. It's given an identifier. In other words, it's given a name. And the difference is a constant will not change while the program runs. So, for example, pi is the example that everyone uses for a constant. Okay, it's not going to change. So you can set it up once and boom, that's it. And you'd probably declare that fairly early on in your program. Then we've got this other notion about constants. Okay. So, and a global variable or a global constant, rather, what's different about those? Well, if you imagine a scenario where, let's say, for example, you are writing FIFA, it's not called FIFA anymore, is it? You're writing football 28. And you've got certain variables that are going to work across the entire program, but you split your program into different modules. So the idea of a global variable is that if you declare it with the word global in front, so declare your variables, that's the most worst circle ever. Declare your variable as you would do normally. There we go, that's slightly less horrible. Except stick the word global, write the word global in front, and that means that it will apply across all of the modules of your program. I have yet to see them ask a question about global, but it's sat there since 2016 in the specification, so this might be the first year. There could be a mark for you somewhere in there, okay? So declare your variable as usual, but then put the word global in front, and that means it will work across all the modules and submodules, etc., of your program. All right. Now, obvious things is that when they ask you to write a program, they will ask you to do an input command. And so this is an example. My name equals input. So please enter a name. Let's just spend 20 seconds on this because there's an awful lot going on here. So first of all, if they ask you to write a program where people will enter their name and it gets stored as a variable, well, this is what we're looking at here. So the variable is called my name, and thinking about using robust programming techniques, giving variables sensible names that are recognizable is one of those ways that you can make a program reliable and robust. So my name equals input, that's the input command, and then putting some kind of a question inside speech marks and brackets, that means that will appear on screen. So that will print on screen. On screen will print, please enter a name. The user types in John, and that gets saved inside the variable called my name, which is a location in memory whose value may change when the program runs. It may not, but it may. So they do like a question on variables because it's really important you understand what they are. Okay, the other one is standby, it's print. Now that's the output. And so if you're looking at something in paper 2 section B, the output command is pretty much always going to be print, okay? So you will probably get a mark for just doing print, and you will certainly get a mark. I calculated it in the last exam. There were 4 marks for just knowing this particular piece of code, and obviously knowing when to use it, but there were 4 marks for it. So it's pretty straightforward, isn't it? So that is definitely worth going away and learning. And like I say, I try and get my students to think about declare your variables first of all. Get those out of the way. Thinking about cognitive load, right? Reducing cognitive load to as little as you actually need to worry about. It means breaking it down into smaller jobs. Decomposition, which is something we talked about earlier. So declare your variables. Get your inputs sorted out like this. My name equals input, whatever you've got to do. Think about your outputs, and then you can think about what sort of code am I going to have to put in here? What are the constructs that this is asking me to do? And then you can go hunting for your constructs and try and get the constructs right. And oddly enough, in these types of questions where it's 6 marks or so, it's only about 1 mark for actually getting the calculation right. They're trying to give you marks. Doesn't always feel like it, but they're trying to give you marks. So just sort of try to break it down into, what are my variables? What are my inputs? What's my output? is this going to be is this going to be iteration? Is this going to be selection? And then sort of go forward on that basis and just break it down so you see you've got one job to do at a time. It makes it so much easier. Okay, talking of constructs, let's just really quickly recap on the three constructs. The first one is sequence. Now, you've got sequence, selection, and iteration. Now, sequence, the idea behind sequence is that when a program runs, it starts at line 1, and it will run in sequence going through line 1, 2, 3, 4, 5, 6, 7, 8, 9, and so on until it comes to an end, unless you put in another construct which actually changes the flow of data. So, for example, it might go from line 2 to line 6 and from line 6 to line 2, and that's where you're going to be using selection or iteration to alter what happens next. So that's the notion of sequence there, okay? So let's push on. Sequence, I think, is dead easy. We've got selection. Selection is when you can weave an if into your question. So selection consists of an if statement. It's when you've got multiple conditions. If this is the case, do that. Or else, if that's the case, do that. Or if that's the case, do that instead. Things worth remembering here is the format of this, and I mean the number of mark schemes where it's got the bullet pointed mark schemes and it's trying to give you marks, and it'll say using if 1 mark. So if you're absolutely all at sea, try and put an if in there. You might get a mark. Don't leave it blank. I'm sure you won't, but don't look at it and just think, oh, it's too complicated. Try and break it down. Think about your variables, strip those out, and then move forward. Think about your input commands. You can probably do those. Think about the output commands. Is it going to be selection? And they find it very hard, as I mentioned last week, to include selection in a question without using the word if. It's quite a tricky thing to do. A couple of things about the if statement for you. It starts with, stand by, the word if, and it ends with the word end if. And then really the sort of anatomy of this is that you've got, if this is going on, then do that. And then you might only have 2 conditions, in which case you'd use an if and you'd use an else. However, if there are multiple conditions, you would then use the else if to actually include those multiple conditions. However, the last condition always has to be an else. So you have to have the if and the else, and you might need some else ifs in there as well. They very rarely go beyond 1 or 2 else ifs in the exam because there's just not enough time to do a question like that. So this really exciting piece of code is saying we're going to start an if statement. So we've got an if statement here. If in that variable is stored the word a, so clearly prior to this, and this is what students often get concerned about, they look at a piece of code and think, well, it's not complete. Before this piece of code was written, there's clearly been some kind of code that has taken in user input. So it said to the, this is also the most boring piece of code in the world. So it said to the user, please enter A or B. And then if they type in A, it'll check it and say, if they've typed in A, then print you've selected A, or else type in you've selected B, or else type in, or else output unrecognized selection because you've not typed in A or B. So a very tedious bit of code, but that's really what an if statement is all about. I did this last week, so I don't want to hang around too long on this because there's still quite a lot to do. 18 minutes in. Okay, once we do the if statement, the other variety, the other flavour of selection is switch case, which actually is easier. I think we should probably teach these to students first of all, but the if statements tend to appear in the exam more frequently. They tend to use these less frequently. So switch case does exactly the same thing. It's exactly the same piece of code, and it works in a very similar way. You start with the word switch, and guess what? You end with the word end switch. And then rather than doing else and else ifs, you just do case A, do this, case B, do this, and the default, that's the catch-all. So you often use the else and the default to catch mistakes. So if someone's typed in the wrong thing, or if they haven't sort of followed the rules you've asked them to do, if they've typed in more than 8 letters, if they've typed in, for example, think about when you're putting in a phone number, and it'll always spit back at you, that's not a phone number, because it'll count how many digits you've got there, and if it's too many or too few, then it'll spit it back. So an if statement could be used for that, or case select, sorry. Okay, we're into the 3 types of loops now, a while loop and a for loop and a do loop. I'm going to jump into these 2 together and then look at No, I'm not. I'm going to do the while loop and the do loop together. Let's do that first. Why am I doing that? Because these two fundamentally do the same thing. And while you need to recognize these in case they ask you a question with these there, in truth, you only have to use one of these. I'd recommend using a while loop. Well, it doesn't matter which one you use, but the only difference is that one checks the status at the beginning and one checks the status at the end. Okay, it checks the condition. So if you've got a while loop, while input entry is this, do that. Whereas the while loop checks it at the end. It says do that until. But fundamentally, they do exactly the same thing. I took it on myself a year or two ago to go and to speak to some full-time programmers and find out which ones they preferred to use. And they all just use while loops. They said, yeah, we could use a do loop, but the while loop can do the same thing. So fundamentally, they do achieve the same thing, all right? And at this point in the course, just pick one and make sure you know it. Okay, you've got to recognize both. So these are both condition-controlled loops, that something will continue until something else happens. The trick is, in exam conditions, when you're stressed and you're on a wobbly desk with a see-through pencil case and your heart is beating, can you find in that question something that makes it clear that a part of the program is going to run until someone types in something and then something else happens, and that will trigger something else happening. So I think that's a really good way of searching for it, okay? Is there an if in it? There might be an if statement. Does something happen, and then if someone does this, then something else happens? That's going to be a while loop, okay? So again, what do you do? While this is going on, do this, and then end while at the end of it. Okay, so that sort of format works across all of these. Lastly, we've got a for loop, and that is our counting loop. So for I equals 0 to 5, do something, and then it'll go next I, which actually should be in there, but it's not. Okay, so the next will take it round to the next iteration. It'll go round and round and round. Okay, I covered those last week, so make sure that you are happy with those three. I mean, if you are struggling with this bit of the course, go and learn the anatomy of an if statement, learn the anatomy of a while loop, learn the anatomy of a for loop, and make sure that have a bit of practice with paper 2 in terms of pulling out the variables first and then getting your input and your output statement in, and then work through the rest of it after that. That would be my advice at this stage, okay? And try to get as many marks as you can by just putting what you can pull out from it on paper. Okay, string manipulation means literally you have a string which is a variable, and we know that it can be any alphanumeric character, any special character. It can be anything, okay? And you can play with it. You can do certain things with it. So let's have a look at what you can do with strings, okay? So first of all, you've got the length of a string. So you can use len to discover the length of a string, and that is how many characters you've actually got in the string. You can also do this fellow here, which is topic equals computer science, okay? So that is the variable, and you can see it's been saved. So a variable is a location in memory that's given an identifier, a name, and its value may change while the program runs. Don't worry, this isn't some kind of strange religious sect where I'm saying the same thing over and over again, but it always turns up. And if they do a 3 marker on variables, you're in a really good place. So let's take, for example, we're now looking at this example of topic, which is our variable. The topic is called computer science. There it is. And you can play with it. You can do various things with it. So if you use the code topic lower, so there's that variable name, we just do dot lower, you can turn it into computer science to make it all lowercase. If you do topic upper equals computer science, sorry, if topic dot upper equals computer science, then you can change it to be uppercase. So that's one of the things that you can do with strings. One of the other things that you can do is concatenation. Nothing to do with cats, no cruelty involved. It means that you can join 2 strings together. So typically, they might give you something like a forename, which is a string, and they might give you surname as a string, and it might ask you to produce a third variable using concatenation, which means you're simply going to take forename plus surname, and you need to create a whole name equals forename plus surname, for example. I hope that makes sense. So that's concatenation, which is again worth a mark or two. Right. So substrings. Let's have a look at how this works. So we're going to look at some more string manipulation now, and we're going to look. So substring, by the way, which is a phrase that sometimes confuses students. Substring means a part of the string. Okay, so it means you're looking inside the string, and you're going to end looking at a part of it. Okay, a substring. So here we've got again the example of subject equals computer science. So we've got a variable called subject, and that has been assigned the value of computer science, and that's a string. Okay, we know it's a string because it's in inverted commas. That's what makes it a string. So if we did subject, which is the name of our variable, dot length, and there's the command for you, that will output the value 15. Why will it do that? It will do it because there is 1, 2, 3, 4, 5, 6, 7, 8 with a space, 9, 10, 11, 12, 13, 14, 15, 16. My arrow won't reach. My desk isn't long enough. There we go. In other words, that's a painful way of me saying it's got 15 characters. Spaces are a character because they have to be shown on screen. They've got to have a value. So don't forget that. So that's 15. Although I didn't put the space in there. But anyway, so that gives you the value 15. Now, next bit is substring. Substring here, subject.substring35. This one's a bit more complicated. Let's have a look at this. So 3. So if we go 0, 1, 2, 3, and then it reads 5, which is Puter, 1, 2, 3, 4, 5. So let's try that again with a line, see if that makes a bit more sense to you. So when you see substring 3, 5, and of course they can ask you to do this, what that means is the first digit is how far into the string you read, but you start at 0 because strings are 0 indexed, okay? Just like arrays, lists, they're 0 indexed too. So if we start at 0, so what it's saying is go 4, if we count each letter, into the word or the string, and then read the next 5 digits, okay? So let's try that. So we're going to go, because we're going to count 0, 1, 2, 3, so that's 4. So let's go 0, 1, 2, 3. So now we're sat on the P of Puter, okay? And then from here, we've got to read 5. 1, 2, 3, 4, 5. So that's why when you see substring 3, 5, you end up with Puter, okay? Good. That's that one, and then this one's pretty straightforward, actually. If you think about this one, what is this? Substring left 4, and that means it starts at the left, which is where the C is. You could, of course, do substring 0, 5. That would do the same thing, okay? Or 0, 4, sorry, would do the same thing. So what this means go to the left and then read the next 4. 1, 2, 3, 4. Easy peasy. And this one is exactly the same, but you start at the right. So we go over to here. Okay, we go to the right and we read the first 3. 1, 2, 3. So that's nst. All right, so we've got nst, comp, and Puter. Happy? So those are the string manipulation part there. Where are we? 58. We are motoring. Random number generation, again, in the specification, not something they ask very regularly. They may ask you to create a program where you generate a random number. Again, I always say it's easy. It's easy when you know how to do it. So the way that you do it, the anatomy of doing a random number is this. So first of all, you have to use, you've got to use a variable. So let's declare one of those, number equals. Okay, so that's gonna create the variable in which this random number will sit. You use the word random, which is pretty standard for a random number. Open a set of brackets like so, and then you're going to talk about so for example, if they say create a number between 1 and 10, this will be the first number, this will be the last number. So that's the anatomy there, okay, separated by commas. So this would become num equals random 1, 10, and that will create a random number between 1 and 10, which is stored in the variable number. Happy? Easy peasy, isn't it? Yeah, it's easy peasy when you know it. Right, array. Not a ray of sunshine, but it's a list, okay? So in computer science terms, an array is a list. It's a computer sciencey term for the word list. So it's simply a list, all right? So the easy part up the top here is what's a list? A list can store multiple items of data. Why have arrays? Because it saves having to create a variable for every single thing. Say, for example, you're writing a shopping list and you had cheese, ham, eggs, bacon, cauliflower, margarine. That's a strange list. You wouldn't want to create a variable for every single item. So instead, you would create an array and then store the items in there. So one identifier, all your items, right? So rather than having separate variable names for each item. So that's why we have arrays, because it just saves so much time. It's a much simpler way of doing things. So what can it do? It can store multiple items of data, and it includes an index. Now, an index is the position of the item in the array. And hopefully, let me just see if I've got that there. No, I don't. That's really annoying. Okay. So in that case, what I will do is, let's use a text to show you this. Right, let's think very quickly about, are you going to do that for me? You are. Oh, hello. I've done something I didn't understand there. Go away. Right, let's try that one more time. No, it's not going to work. So the key thing with arrays is that it needs an index. So just in the same way as looking at strings, the list starts at item 0. So if you had dog, cat, budgie, the dog would be index 0, the cat would be item 1, and the budgie would be item 2. Okay, so they start at 0, which is why sometimes in pseudocode you'll see -1 at the end. You know, because of that reason. So when you're creating a list, the data in the list has to be of the same type. So you can't have a mixture of strings and integers and floats. It's got to be one data type. It also has to have a fixed length. So let's talk about how you declare an array, and it's a type of variable, isn't it, fundamentally? You name the array, so what you need to know is what's it called and how many things are going to be in it. So array color 5, and notice when it comes to arrays, and when you're trying to figure out what a piece of code does, if you see these square brackets like this, it may well involve an array, okay? Because arrays use square brackets rather than the curly brackets that we've used elsewhere. So in this case, we've got array colors 5, which will create an array with 5 elements in it, okay? And you can also calculate the length of an array by using length or .len, okay? So the type of sort of manipulation you can do there. All right. So those are your arrays. Now, we've got a 1D array, which is literally a list of things. But a 2D array is a bit more, two-dimensional array, by the way, that stands for, is a bit more like a spreadsheet, where you've got columns and rows, or a table, so which is a spreadsheet. So when you've got a two-dimensional array, they are referring to a table, okay? So what's a 2D array for? You can store multiple arrays of data. So it is effectively a list of lists, isn't it? Because if you think about a spreadsheet, if you think about a database, that a record is when you go across from left to right along one line, isn't it? That is an array. So if you think about what the NHS, the information they've got on you, it's going to be first name, surname, date of birth, address, previous health conditions, that sort of stuff, right? And that's going to read as one line across across a spreadsheet. That's going to read as a row, all right? Whereas a 2D array, that's going to be multiple rows, okay? So that's how it works, with each row being a one-dimensional array. But if you want an array of arrays, then you've got a 2D array, okay? Again, the data has to be of the same data type, and it includes an index, and it's 0 index. So in the same way, you're going to declare it in exactly the same way. You've got array colors 5, 6 here, and I really recommend you have a look at towards the end of the specification. There's some really good examples in there that can help you to understand this better. And if you're still struggling with it, ask Mr. Godfrey to print off some, or to give you electronic copies of some of the past papers that include array questions, because they take a little bit of getting used to, but actually the principle's really simple. So if you do array color 5,6, again squared brackets, notice that bit there, squared brackets, it creates an array of arrays with 5 rows and 6 columns, okay? And it can be used to emulate, which means to sort of copy a database. Actually, emulate isn't copy. It is copy. Let's use that word, an emulator. All right. Any questions, do shout, because I'm moving quite quickly. Any questions that you've got with this that I can't answer today, again, make sure you ask Mr. Godfrey. You only got a lesson or two left. He could possibly run through this with you, or sorry, whoever your computer science teacher is. Okay. Now we looked at SQL. We're getting towards the end here. SQL stands for Structured Query Language. It's a language that's used to interrogate, to question databases. Example being, you work in a shop, somebody comes in and says, have you got this album in stock? I mean, assuming that they sell albums in shops anymore. They don't really, do they? Because it's all downloads. But you would go to your computer, you would open the database, and you would type in the name of the item, and you'd run a query. If you wanted to know who the salespeople who've sold the most products are, you could use SQL to write a query to question the database on something that you want to know. So that's what SQL is. It stands for Structured Query Language, and a query is a question, okay? Have you got any queries? So data will be stored as a record with different attributes, okay? Name, age, address. So when we've got the idea of a record is one row of a table, whereas an attribute is a column. And I know it's a bit confusing, but it helps to understand these words, all right? An attribute's a column. So let's think about what you need to do to interrogate, to question a database. I'll tell you what, it's so easy, it's absurd. You've only got to remember 3 fundamental things, possibly 4 if we include wildcard. You've got select, you've got from, and you've got where. And the way that they structure these questions, this will be a 4-mark question, so half a grade boundary in paper 2, and you need to use those 3 words. However, you can't just write select from where. I've told my students to write those 3 words and to put the asterisk on the side so they can literally do a brain dump when they see an SQL question, thinking about cognitive load theory, because you know that the code you're going to have to write is going to contain those 3 things. Yes, there could be some operators. There'll be a greater than, less than. There could be an and, an or a not in there. There could be a not equal to. But fundamentally, those are the 3 ideas you need to slot into place, okay? So let's first of all think about select. So select relates to the columns that you're going to be looking at. So they'll give you a scenario and say, here's a table, there's always a table, and have a quick look to see where the table name is, because the table name we'll come back to in a second, all right? But we are currently looking at select. So I'm focusing on this first command here. And you can see down here, we've got select age, comma, address. So say, for example, you've got a spreadsheet with people's details on it, and it's got the following columns. It's got name, age, address, and telephone number, right? And they might ask you to create an SQL query which shows the age and address only for people who are over 15, for example, all right? So that's the sort of calculation you've got to do there. But select simply means which columns do you need to look at. If it's more than one column, separate it by commas. If it's all the columns, that's when it comes to this last thing here, the wildcard, the asterisk. Because asterisk is like doing Control A, it's select all records, okay? So you could possibly do select star, so you'd use select asterisk for select all, okay? Or you pick the columns that you want to look at. So that's your first thing that they're going to ask you. The second thing you'll get a chance to use is the from command. Now, from just relates to where is it? Where's the data I'm looking for? I know the where's confusing here, but the from relates to the table. So they will give you a table name. So they'll say this table is called student record. So you're going to say from student record. Simple as that, okay? And then lastly, we've got where. and that's where you're going to put in your conditions. So from, just to recap, that's going to be the name of your table, and then lastly, where is where you're then going to use all of those sort of operators to try to only get the data that you want from the table. So that'll be where age is greater than 6, or where age is greater than 6 but less than something else, or where age is not something. Any of those sorts of things. And of course, you might need to join these together, the where something is this and that, or where something is this or that, or where something is not that. So those are the toys you've got to play with when it comes to an SQL command, all right? Again, these are they're pretty much always worth 4 marks. There's half a grade boundary in an SQL question. So it's really worth having, and I don't think it'll take you, I did this with my class last week. I don't reckon it, within 15 minutes, I think 26 people in the room were going, oh yeah, okay, this is quite easy, isn't it? Yeah, it is. It's really formulaic. And they're going to give you the table name, so you've got 1 mark there straight away. So you might find it easier if you're not too great at these, to write down, select from where and asterisk, and then just use the ones that you need to. So that, guys, is SQL for you. Okay, we've got procedures and functions to jump through now. So let's think first of all, words, parameters. Parameters is a word that often confuses people, and these are values that are stored as variables that are passed into the subroutine. So a procedure is an example of a subroutine, and it's a way that you can improve the maintainability of the code. And a procedure, or we'll go to a function in a second, but the advantage of declaring procedures and functions is that it's a snippet of code that you can reuse as many times as you want, and you simply call it. So you give it a name, and if you need to use it, you call it. So rather than rewriting the same piece of code as and when you may need to use it in the program, you write a procedure, and then you call it when you need it. And all you've got to do is feed in the right numbers to it, and those numbers are the parameters, and they are stored as variables. I've said the same thing twice. I hope it made sense either time. So what it does, the procedure can be used to run a sequence of instructions. It'll take parameters from the main program. Now here's the thing. You've got a procedure and you've got a function. And the key thing with procedures is that they do not return values to the main program. So for example, I've been trying to keep track of the miles that I go walking, all right? And a better example is BMI. You put in your age, you put in your height, you put in your weight, and then you press a button and it shows you your BMI. Simple as that. That would be an example of a procedure. However, a procedure, the number that you've produced doesn't then get used to do anything else as part of the program. That's where we're going to look at next, okay? So in the example you've got here, this is the anatomy of a procedure. First of all, you use the word procedure. And I mean, how many times have we seen this today? Can you stop doing that, please? Thank you. And again, stop. Good. Right. Procedure and end procedure. Again, sometimes they give you a mark for writing down procedure. And if you write procedure, write end procedure as well. And then put your code in between it. Give it a name. Sometimes they give a mark for giving the procedure a name. And then the parameters, using brackets, that is where you're going to put in the variables, the figures which are stored in the variables. That's where you're going to put them in there, okay? If you've got more than one, separate them with a comma. And then the last part is you put whatever code, whatever they're asking you to do, in there, all right? So that is your procedure. Right. Difference between procedures and functions is a function does return a value to the main program, and that is pretty much the only difference, all right? So let's run through what happens. It's exactly the same. So how do you declare a function? You write the word function at the end. You write the word end function. You give it a name, give it a sensible name. You then open up some brackets and you put the parameter, the variable or variables that go in there. And again, I'm kind of repeating myself here, but students often get confused. They'll look at it and go, well, but no one's collected the variables. We don't know what they are, so I'm going to write a bit of code to get user input. No, 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 no. What they sometimes ask you to perform some kind of well, I was going to say function, but they sometimes ask you to write a piece of code, but there's an assumption that other data's been collected first. So if they ask you to create a function, it's probably going to be they've already written a command to collect user input from the data, and that data is already sat in, well, it's sat in a variable or it's sat in an array, and then you've got to question it using a function, okay? So function, end function, give it a name, say which parameters are being used, separate them by commas if there's more than one, and then you put your code down here, all right? So that is what a function does for you. So procedures and functions. Right, last straight now, 1:15. I've got another 5 minutes to do, guys. Let's look at file handling. They might ask you to read and write data. So they might ask you to create a program where you read some data from a text file. It'll usually be .txt. It'll always be something .txt. So they'll ask you to read a file, which obviously you need to open, you need to read it, and then they might ask you to add something to it and then close it, okay? So let's very quickly look through the different commands that you need. So if you want to create a new file, you've got to give it a name, and then you're going to use the command new file, and then you're going to say whatever you want to call it, okay? So that will simply create a new file, all right? And if it could be file name.txt, whatever it is that it's called, okay? Then you might need to open or close that file. And obviously you'll open it at the start, you'll close it at the end, okay? So to use open, you simply use variable name equals open file name. So don't forget, with all of these, you are storing what you're doing inside a variable. So that's the variable where you're going to store this, so you can do stuff to it. This is bringing the variable into existence. This command, the open command, is going to open whichever file you list here. And then you can start to play with it. You can read from it, you can write to it, and then you can close it, okay? So then you've got the idea about how do you read. And by the way, closing is exactly the same thing here, except it's the word close, all right? Again, look at some examples of these. It's much easier if you scan through some examples. Let's look at reading now. So this is how you read from a file. So they might have given you a file name, and then if you want to read the entire file name, the entire file, you simply put in the variable name like so, and then there's the variable name which is there. Then you put in the full stop or the period as the Americans call it, and then you simply use the command read, okay? So that's what you need to do to read it. And then you might, if they ask you to do it line by line, then you would say read line and put the line number in there. That's all you've got to think about, really. If you write to a file, exactly the same thing. You just use the code write line. I'm acutely aware that I have gone over time here. Good, I made it. All right, good. I hope 7 of you are here, which is good. I hope that was useful to you. More importantly, if there's anything that I've gone through, particularly in the last 10 minutes where you're thinking, oh, I'm a bit dicey on that, my recommendation is, with the limited time you've got left, type in J277 specification and then go to, because you'll see where because this was my starting point. For any teacher, their starting point will have been J277, because that tells us what we've got to teach you. And it's got to be simple to understand because teachers have to use it. So if you type in J277 specification into any browser, you end up with something a bit like this. And there's my J277 because I've looked at that before. You click on, yes, whatever. You click on download GCSE spec, and here it is. And what I wanted to show you was that you've got, first of all, the list of topics, haven't you, in the syllabus there. And then if we just make that a bit smaller and then get down to here, as we scroll through it, I've got a bit more real estate than that. Bear with me a second. If we scroll through it, you can see there's paper 2, what's in paper 2. We've done that today. That's what we've done today. I showed you that at the start. And then we've got Boolean logic we'll look at next week. And then I think it's next week. And then if you scroll down and keep going, this you'll recognize, okay? And if you go to here, it's exactly the code that you need to use. And if you keep going, you will end up with, there's our list of constructs there, for, while, and do. There's our selection, if, then, and case select. And look, here's what I've just been doing with you, okay? Didn't have time to do ASCII conversion. We've got concatenation, uppercase, lowercase, substrings, all the stuff we did today. And you can see there, in fact, is the exact example that I used with you because I stole it from here. And then you've got the read line and write line. Declaration, I did arrays with you as well. I mean, at lightning speed, to be fair to you. Random numbers, okay? That's all that it is. The other thing you might want to glance at down here is that the exam's a whole lot more less confusing if you know what the command words they use in the exam are. So scan through those just to make sure you understand what they actually are asking you to do. And it might be you get to one and think, oh, I didn't understand what that meant. Identify is one of those, justify is another one, and evaluate is another one. So think about those. Who's behind the door? You are ever so welcome, and well done for sticking around so long. I will see you guys next week. Have a lovely week, and we'll do a bit more of the same. All right? Well done, guys. See you next week. Cheerio. Bye-bye.